Yeah, this is a fun one because we get to have a car figure out what the max speed is for a car to actually get lift off of a hill. So here we go. We've got a straight surface here. We've got a hill, whoop, and then down. So again, it gives us a radius. If we were to draw a circle here, radius here is 100 meters. Okay, and basically we're looking for, here's our car, we're looking for the max speed of the car to stay on the road. So, now again, it's hard to depend on formulas if you're not quite sure of the situation. Okay, what I just said was that the car needs to be starting to lift up and kind of fly off in this direction. We need to find out where the weight, the apparent weight, or the normal force is equal to 0. Okay, so we already know that the normal force in a situation where the car is at the top of the hill, it's mg minus ma. Okay, the normal force is the gravitational force times the mass, subtracting the mass times the acceleration of the car. Now, we are looking for a velocity from here, so mg minus mv squared over r. Okay, so if we know that the normal force is 0, mg, 1200, okay, 11,760 newtons. That's the weight of the car if it weren't, accelerating. There's the weight of the car minus mv squared over r. Okay, so let's take the mass and the radius and put them in there. So I'll bring this up here. So 0 equals 17,600 minus 1,200. We're going to get rid of a couple zeros here. Minus 12 v squared. I just get rid of a couple zeros, so we're at just arranging it that way. Okay, so I can bring this over to this side if I'd like. So 12 v squared is 17,600 newtons. Divide by 12. And guys, the math, the way that you arrive to your math may be a little bit different than I do, and that's okay. 17,600 divided by 12. So v squared is 1466.7. Let's solve for the velocity. So the square root of that number. Okay, velocity is 38.3 meters per second. Now, at 38.3, this thing becomes weightless. Okay, it begins to fly off of this hill. So you don't want to go much faster than 38.3 meters a second up the hill. Otherwise, you fly off. Right? So that's what we're looking at. And you can do a conversion if you would like to. just to kind of get an idea of the mile per hour speed. It's more in your language, but that's it there. You don't want to go faster than that. All right.